All right, ladies and gentlemen, this is your video lesson for 1.3, solving multi-step equations. So without any further ado, I'm going to get right on to it. Remember, these are the exact notes that you guys were given in your notes packet. Remember, there is a difference between your notes packet and your independent practice packet, or I should say your assignment sheets packet. Make sure that when you're turning in assignment sheets that you're actually turning in assignment sheets and not pictures of your notes. So let's make that distinction. The first thing I'm going to look at, I'm not even going to really go through these. These are a warm-up. So if you want to take a look at the answers, just hit pause on this video and you'll be able to see what they are. So I'll just briefly go through them so you can see and you can pause. I will, I guess, talk specifically about this problem here. This one, remember that -5 that's being squared, the -5 is in parentheses, so that's -5 times another -5, right? And a negative times a negative is a positive. And so that's why we get a positive value there. The reason that this one ends up being negative here, we get a -27, is because I have 3 instances of that. So a negative times a negative is positive, but then times a negative again becomes back to negative. So I just wanted to make sure we made that distinction. Here's the next warm-up problem, two-step equation stuff. What are our forward steps? What's happening to x? I'm multiplying by 4, and then I'm adding by 2. Remember, I then undo that stuff. So I undo my last forward step by subtracting 2 and then dividing by 4. And here's the correct work for that. You can kind of pause it and take a look. On the next page there, this problem was happening to x. I'm multiplying by 5 and subtracting 23. So I'm undoing the last forward step and making that my first solving step. So I'm adding 23, and then I'm undoing multiplication by dividing by 5. You can see the work there. And this is very much the same. So I'm going to throw up both of these here so you can take a look. I'll put my picture, I guess, in the middle so you can look around me. Pause the video if you need to take a look at the answers. All right, so all of those were examples of two-step equations that you were just going through, and that was what we talked about last class. So or 2 classes ago, actually. If you're watching this video now, we've already had the class for multi-step equations, and so this is a video supplement for that. So remember, when we're solving equations, what we very first learned is that when we're evaluating and they are not equations, no equal signs, right? We use the order of operations in order to decide what to do first, second, and last, right? So first we did parentheses, then we did multiplication and division, then we did then we did exponents, and then we did multiplication and division third, and then we did addition and subtraction last. So that was the order of operations. Then we talked about how when we solve, we also have to have an order. And the order is the reverse order of operations. And we still undo those things, but we stand that on its head. So for example, that's why we list out the forward steps on this one, like what's happening to x, what according to the order of operations, what would happen to x. We'd multiply first and then subtract 23. And then we reverse that order, and then we undo those things. So that was our whole premise, right? And that does not change when we have multi-step equations. However, there are other things involved in solving multi-step equations. Let's take a look at this example, okay? This example, I want you to think about what your first step would be. And the most common error that I would get would be students would say, oh, well, what's happening to x? I'm multiplying by 2 and I'm adding 5. So most students will say then, oh, I subtract 5. But that's not really true, because here's what you need to understand. 2x plus 5, when it's being divided by 3, I'm not talking about the whole equation. I'm just talking about this part right now. When it's divided by 3 like that, that is just a shorthand way of writing 2 separate division problems. Because what we really have is 2x divided by 3 plus 5 divided by 3. So if you were to say that your first step should be to subtract 3, that's wrong, because it's not really, subtract 5. That's wrong because it's not really 5, it's 5 divided by 3, okay? And you can't undo the multiplication of 2x by dividing by 2, because it's not really 2, it's 2/3, okay? So then in a problem like this, what in the world do we do then, right? This division, this division by 3 is really screwing stuff up. So the question is, well, what do we do? Let me get rid of this. And here's the answer, right? This is how I like to think about this problem. When you think about this problem, the whole numerator is locked up by this division of 3, okay? And we unlock it by undoing that division. So that we multiply both sides by 3. And when I do that, it sets the numerator free, and I'm left with just that 2x plus 5 is equal to, and then I would have 30, right? And that strategy is called clearing fractions. Clearing fractions. I'm not going to write the original equation here, but I am going to write that. Clearing fractions. Clearing fractions is our awesome fraction strategy because it gets rid of fractions, right? We don't have to deal with the fractions anymore. And the way we clear fractions is by undoing the division, which a fraction really is, right? It's kind of division. We undo that with multiplication. So we clear fractions by multiplying out the denominator. Okay. So in solving this problem, our first solving step was actually to multiply by 3, right? We had to clear the fraction. And now when I look at this, well, what are the steps that we need to do to solve, right? We need to subtract 5, and then we need to undo the multiplication by dividing by 2. What you'll see today is that we are no longer going to work with these boxes. These are kind of like your training wheels for solving equations. And today the training wheels are coming off. You guys are going to learn how to solve equations without actually needing this anymore. You're going to hopefully develop some good thought processes where you don't have to do this kind of stuff and you can go right to solving it. So if we're going to finish this problem, we're going to execute those steps. 2x plus 5 is equal to 30, right? And I'm going to execute that. I've already divided by or multiplied the 3 out. I'm now going to subtract 5 from each side. That's going to give me 2x is then equal to 25. And then I divide by 2. And then I will get x is equal to 12 and a half. Okay, so that is our first multi-step problem. But again, this problem is very important because we're talking about this idea of clearing fractions. Remember, everything in this numerator was originally locked up by that division of 3. And the way we undid the division of 3 is by clearing fractions. And we clear fractions by multiplying out the denominator. All right, let's look at some other things that we're going to have to do for solving multi-step equations here. So to solve multi-step equations, we must always simplify as much as possible before we complete any solving steps. That means the following. We are going to get rid of parentheses by using the distributive property first before we do any solving. We are going to combine all like terms first. That means if an equation has a 2x plus 3x, x, that's an x, by the way, I am not going to divide by 3 to undo that. I have to add those together before I can do any type of solving step with that. Okay, so always combine like terms first. And then if variables are on either side of the equation, so I have a 2x over here and a 4x over here, I need to get them on the same side of the equation. And we do that by doing the opposite operations. So in this particular example, let's say there's like a plus 8 over here, right? 2x is being added to 8, so I have to subtract 2x to the other side, and that would leave me with 2x is equal to 8, and I would work that out from there. Okay. When we're done doing all of these things, typically we'll have a two-step equation, which is awesome because we spent last class going over two-step equation. Let's take a look at some examples. So this is how the video format is going to work. I'm not going to sit and go through every single one of these problems. What I'm going to do is model one of them and talk through one that I've already completed. And that's how this is going to go back and forth, okay? So in this problem, this is an example of, well, really what we had here, right? I have parentheses that I have to get rid of. So I have to distribute before I do any solving. I'm also going to add the opposite here. So 4 times 5 is 20. And then when I take 4 times negative 2, I get that negative 8x, and that's still equal to 20. Okay? Now, when I simplify this, I have a two-step problem, and there's really no simplifying to do. I just have to solve now. I've whittled it down to a two-step equation, which we said most of them will be. And so this is where we don't have the training wheels anymore. So I just asked myself, what's happening to x? It's being multiplied by negative 8, and I'm adding 20. So the last thing I said was add 20. That's the first thing I undo by subtracting 20. On my little vertical line. I'll have negative 8x is then equal to 0. And sometimes students are uncomfortable with that result, but 0 is a number. If you feel uncomfortable with something that you got, just go ahead and check your work. What's happening to x? I'm multiplying by negative 8. I have to undo that with division of negative 8. That's an 8. Divide by negative 8. And x is equal to, how many times does negative 8 things go into nothing? That answer is 0. So our answer here is 0. All right, kind of modeling that same idea here. This one, again, you should try this one on your own first and then look at the answer to this and see what it is. So go ahead and try it on your own. Pause. All right, good job. You did it on your own. Welcome back. The first step here, again, is to get rid of the parentheses, just like this problem, and distribute. Okay. So when I do that, I get negative 10x, and then negative 2 times 1 is negative 2. Don't forget that you should add the opposite here. If you have a positive 2 here, it's because you forgot to do that, and that ends up with making a sign error. I then need to combine those like terms, 4x and negative 10x, to get negative 6x. I don't know why this keeps going up and down. And once I've done that, I've now used the distributive property of combined like terms, and look, I have a two-step problem. So what's happening to x is being multiplied by negative 6, and I'm adding negative 2. So I'm going to add to both sides as my first step. When I do that, I get 18, and then there's only one thing left happening to x, and that is being multiplied by negative 6. So when I divide to undo that, I end up with an answer of x equals negative 3. All right, next problem here. So again, modeling this one. This one, I have the distributive property. So I'm going to distribute a 3. And nothing else to combine here at all. So I'm going to go ahead and work that out. So I have 6x plus 21 plus 5x equals negative 23. So I'm done with the distributive property. No more parentheses, but I do have like terms I can combine. So I have 6x plus 5x, which gives me 11x plus 21 is equal to that negative 23. Okay. Then now I have a two-step problem. Okay, so 11x plus 21 equals negative 23. I will subtract 21 from both sides. Here's my little line down my equation to show both sides of it. 21s are gone, so now I'm left with 11x is equal to negative 44. And the only thing left to do is undo the division or multiplication of 11 by dividing by 11. And then I get x is equal to negative 4. All right. So again, pause the video and go ahead and try the next one, and I'm going to walk you through it momentarily when you're finished. Welcome back. Hopefully you've tried this one. Now this one's slightly different because it's got variables on both sides, right? I got a 16x here and a 10x on either side of the equation. I got no parentheses to distribute through. So the first question becomes, how do I go ahead and get all of my variables on the same side? And there are really two ways you can do that. I could subtract the 16x to the other side because it's a positive 16x. That would give me a negative 6x here. I'm not a big fan of having negative signs because I generally make mistakes with those, right? That's the biggest mistake that I see from students. So what you're going to want to do is always move the variable so that it is positive, which means I'm going to subtract the 10x first, okay? Let me just do this here so I don't have any problems with that again. So I'm subtracting the 10x first. When I do that, 16x minus 10x gives me 6x minus 5, and now I have a two-step equation, just like we have talked about in the past. So what's happening to x? I'm multiplying by 6 and subtracting 5. The last thing I said was subtract 5, so that is the first thing I undo, so I add 5 to both sides. After I'm done adding 5 to both sides, I get 6x is equal to 24. And there's only one more thing happening to x. I'm multiplying by 6, so I'm going to divide to undo that, and I get x is equal to 4. All right, next problem, example 4. So for this one, I have variables on both sides, and I also have, so I got variables here and here, variables on both sides, and I got the distributive property. So there's a lot of things going on here. Let's check this one out. So first I have to get rid of the parentheses by distributing. So I will have a 6x plus, I'm going to change this to add the opposite, 3 times negative 5 is negative 15. And then I have to carry down the rest, right? So plus 7 equals 12 plus 5x. Just verifying that I didn't make any mistake there. I think we're good to go. All right. So I'm going to make the line for both sides of my equation as I'm working down. And now what do I have to do? Well, on this side of the equation, I have like terms to combine. So I'll have 6x. 6x. And then negative 15 plus 8 is negative 8 equals 12 plus 5x. All right. Now I got variables on both sides. So remember, our strategy that we want to do is move the variable first always. Move the variable first always. Move the variable first always. What do you move first? Variable first, always. So I want to move it so it's positive, so I'm going to subtract the 5x rather than subtract the 6x, so I have a positive result. So that gives me a 1x minus 8 is then equal to 12. I will then if I look at what I have left, I have it's really just a one-step equation, but we're going to turn it into two and we'll talk about it. I have to add 8 to both sides to finish this off, and I'm left with 1x is equal to 20. Now, really, I have no other steps left to do because I have a 1x, right? So really, the answer that I have here is x equals 20. Some people will go further and be like, well, I got to divide by that 1, but you really don't, because what's 1 divided by 1? It's 1. Right? So dividing by 1 on this side makes no difference. And then what's 20 divided by 1? It's 20. So our answer is x equals 20. If you have a 1 like this going through, you can really just get rid of it because we never really write that 1. All right, so I'm going to go ahead and do this first. And then we're going to talk about the next one. Get rid of that mark. And then let's grab this. So in this particular problem, I have 2 instances of the distributed property. And I want to kind of focus in on this instance of it right here. So right here, I changed this to add the opposite, and that turned this into a negative 3. If I don't do that, I might end up distributing a positive 3, which means this sign on here will be incorrect. Make sure that you do that before you distribute every time. So talking through this one, I'm going to distribute the 13y. I'm sorry, 13, I'm going to distribute the negative 3. In doing that, 13 times y is 13y, 13 times 1 is 13. And then distributing the negative 3, I'll have a negative 6, and negative 3 times 4 is negative 12y. And then that 38 just goes along to the right. I then have variables on the same side of the equation. It's not on opposite sides, right? So I don't do the opposite operation. I just combine like terms. That's one very common mistake that students make. They always think they got to do the same thing to combine the variables. So I'm just going to make this crystal clear here, highlighter. So if the variables are on the opposite side of the equation, like they were here, right? Then you do opposite operations to get them on the same side. But if they are on the same side of the equation, right? There's the equation, and these are on the same side, then all we do is straight up add or subtract when we're combining them. That's a very important part. Okay, so when I'm combining like terms, I should have a 1y here. So 12 plus negative 12 plus 13 is 1. And again, we can just write the y if we want. 13 minus 6 comes down, and then 38. Now I combine the 13 minus 6 to get 7. Scroll down a little bit here. I'm going to subtract 7 from both sides. That gives me 31. And then I'm showing that division by 1, but it is completely unnecessary, as I talked about before, because we just end up with 31 anyhow. All right, next problem here. So this one has got some fractions involved. Fractions are friends because they're like math vitamins. They help us grow, right? So let's talk about this one. I have 2 instances of the distributed property here. So I'm going to distribute the 6, and I'm going to distribute this negative 4. Remember, I'm changing that so I get it correct. I'm also going to change this to add the opposite as well. So 6 times 1/2 b, so it's like, what's half of 6? That's 3b. And then 6 times 3 is 18. And that's now equal to 1 is just being added to all this. I do have to distribute a negative 4. So I get a negative 48 plus negative 4 times negative b is a positive 4b. Okay, so I'm going to draw my line and the equal sign here. And now I'm going to move the variables. Now they are on opposite sides of the equation, so I have to do opposite operations. I'm going to do it so it's positive in the end, so I will subtract 3b from both sides. So I'm left with 18 is equal to 1 plus negative 48 plus 1b. I will combine these like terms. So I'll get 18 is equal to negative 47 plus b. And again, look, I dropped the 1 because I don't need it, right? So then all I got to do is add 47 to both sides. And I end up with 65 is equal to b. Okay, next one. Go ahead and pause, do the problem on your own. All right, let's talk about it. So this one's got kind of like everything thrown at you here. We got the distributive property. Notice we got variables on both sides, so let's tackle it. So the first thing we need to do is to distribute the 5 on the left. And at the same time, again, notice I changed that to a negative. And I'm going to talk briefly about this, right? So I have a negative on the outside of a parentheses. Let's say it's x plus 6 or whatever. What that really means is that I have a negative 1 on the outside, and I need to distribute that negative. Okay, even if it's just subtraction as it appears here. Okay, I change it to add the opposite, and it's the opposite of this entire thing. All that does is change the signs on the inside, right? So this is really equal to negative x minus 6, right? It's the opposite of what's inside of here. And that's really what you're doing. So make sure you understand that that's what we have to do when you have a negative on the outside of parentheses. Okay, so in doing the distributive property here, I have 60. Oh, yeah, I gotta do this again. All right, so 60, and then 5 times 3 is 15x. 5 times 8 is 40, is equal to, 10 goes along for the ride, and then I'm distributing a negative, so negative 1 times 7 is negative 7x, and a negative times a negative here is positive 24. Then I have like terms combined. I can combine my 60 and 40 to get 100, and then I can combine my 10 and 24 to get 34. Now I got variables on both sides. On either side of the equation, there's nothing else to do. And again, because my variables are on either side, I have to do the opposite operation. So right now, on this side over here, I have a negative 7x. So I'm going to add that 7x to the other side. Opposite operation, because they're on opposite sides of the equation. And that gives me an 18x here. Sorry, I did the wrong thing there, didn't I? I get a mistake here, and that's okay. Sometimes I subtracted rather than add. So let me take a look. Actually gives me 22. So I'm going to erase this. So I get 22 instead. 22x. All right. So I get 22x. Then I get 100 is plus 22x is equal to 34. I subtract 34. I subtract 100 from both sides to get. Oh, what happened there? I didn't finish this problem. All right, good deal. So I get, and it's not 8 anymore, right? It's 22x. And then 34 minus 100 is 66. And if I divide by 22, divide by 22, I get x is equal to 3. So that whole thing reduces down to 3. All right, last problem here. So Troy needs to mow a small storefront lawn that is 3t minus 4 long and 70 feet wide. Okay, so let's just stop there and think about this. I have length and width here. So I'm just going to label it. I have a rectangle already drawn. So I'm going to call this my length. I'm going to call that 3t minus 4. And that goes from here to here. And I'm going to call this here my width. And that's 70. And that goes from here to here. All right. So it says if the lawn is 980 square feet, which is an area measurement, write and solve an equation to find t. All right, well, let's walk this through here. So area has a formula of, we're going to do this again. Area has a formula of length times width, right? So what is my length? I'm told that it's 3t minus 4, and my length is 70, and I'm also told that my area is actually 980 square feet. So I'm going to substitute all of that stuff in, and it looks like this. So notice 980 is in for area, my length is 3t minus 4, and my width is 70. Now, back up here, remember area is length times width, right? Which means I'm multiplying. So when I multiply, if I substitute using parentheses like you've been told to do, that means I got to distribute this stuff, right? So that's exactly what I'm going to do. When I distribute that 70 times 3t is 210t. 70 times negative 4 is negative 280. Then I have to solve for t. So I'm going to add that 280 to both sides. That gives me 1260 is equal to 210t. And then the last thing to do is divide by that 210, and I get 6 for t. All right, so that is your video lesson for 1.3, solving multi-step equations. If you have any more questions on that stuff, make sure that you sign up for contact time, email your teacher, but contact us, all right? Yeah, hope you have a great day.